Dear students, welcome to fifth lecture of this course. In this lecture, I am going to discuss computer integrated manufacturing. So let us first understand what computer integrated manufacturing or CIM is with respect to computer aided design and computer aided manufacturing, because till now we have been discussing about CAD and CAM only. Now, with reference to CAD/CAM, CAD/CAM is concerned with the engineering functions in both the design and manufacturing. This already we have discussed a lot of applications of computer-aided design and manufacturing. And whereas CAD deals with product design, engineering analysis, and design documentation, CAM deals with process planning, NC code generation, inspection planning, and all other related functions related to manufacturing. If we want to go for understanding what are the different CAD issues in detail, the basic things or issues that are addressed in CAD tools and software is the geometric modeling is the basic one, as we have seen. Engineering analysis, whether it is mass property analysis, interference checking. Suppose in case of assembly, you want to check the interference of the parts. Tolerance analysis, again, very useful for assembly. Finite element analysis, whether it is for structural analysis or thermal analysis. Kinematics and dynamic analysis, we have seen the mechanism analysis and all that. And discrete event simulation, where you want to see the different things, how they are, for example, in a factory setting, how the men and material are interacting, how the parts are being produced and moved on the show floor, etc., etc. Then you have various functions or issues which are related to design, evaluation, and review. For example, automated dimensioning. You generate a CAD model, you can go ahead with the automated dimensioning, or the dimensioning will be done by the CAD software. Then error checking, um, whether it is error in the some discrepancy in your design or design to manufacturing. Maybe you identify some issues which are bound to occur when you go for manufacturing. So all these things can be done. And animation of discrete event simulation is another thing which can be visualized beforehand. And then we have seen a few examples of plant layout design also in our previous lectures. As far as the CAM issues are concerned, there are variety of issues starting from manufacturing planning and manufacturing control. In manufacturing planning, you have issues like computer-aided process planning, computer-assisted ANSI part programming. You generate ANSI code with the help of the CAD model, and by selecting the appropriate manufacturing resources or machines. Then you have computerized machinability data systems, where you identify what kind of feed, speed, depth of cut, etc. will be useful or will be appropriate to produce that part. Then development of work standards. For example, you want to do time study, you want to do motion analysis in time and motion studies. For example, you are assembling some things, assembling one engine. You want to know what time it is going to take to assemble that kind of engine. And all these things can be done with the help of work standards. Cost estimation, whether you are doing some machining activity, you are doing some 3D printing activity, you can always go for cost estimation. Then production and inventory planning, how you want to plan your production targets, how you are going to correlate your inventory or the your materials as far as so that you can match with the production targets. And then computer aided line balancing. Computer aided line balancing is when you want to balance the various operations in your factory or setting, whether it is operations which are related to manufacturing or assembly. Suppose you are having an assembly line, you want to make sure that whatever parts are required, for example, to make one engine, all the part, there should not be shortage of any of the part when the assembly is being made, because even a shortage of one bolt may hold the whole of the assembly line. Okay, so you want that all the number of parts which are being sent to an assembly workstation are as per the requirement and they are not short. And then you have various functions or issues related to the manufacturing control. For example, process monitoring and control. You want to monitor the process so that you can control the process and it doesn't go out of control. That means it is the production of defective parts is controlled well in time. And uh, then quality control is you are controlling the quality so that defective parts are not made at all. Okay, so the concepts like Six Sigma and total quality management, these are applied in quality control. Then you have the shop floor control, how you want to manage the different resources, which machine is to be assigned with which job, etc. And you have inventory control, like when the new parts are to be ordered, when the raw material is to be ordered, you know, all these things are part of the inventory control, because all these things are linked with the production or the your rate of producing the parts or the components. And then you have just-in-time production system. You always want your inventory to be the low, on the lower side, or the bare minimum, so that the cost of inventory are avoided. So just-in-time production systems are also useful, and they are part of the, all these are the part of the CAM issues. Now coming on to the SIM, or the what are the activities, we will see in detail what are the SIM activities. But as an overview, SIM includes all of the engineering functions of CAD/CAM. All the functions that we have discussed in CAD and CAM are part of SIM. And this also includes, or SIM also includes firm's business functions that are related to manufacturing. So we'll see what are those business functions. They may be related to the finance, they may be related to the costing, etc., or purchasing even. And then Ideal SIM applies computer and communications technology to all of the operational functions. So, whatever we are doing in SIM, we are integrating all the activities, CAD plus CAM plus business functions with the help of computer systems. So, when we say systems, so we mean hardware, software, as well as the communication system. And it also SIM also includes information processing functions in manufacturing, from order receipt, when the order is received by the company, through design and production, so the things when they are designed and produced, and up to the product shipment. The scope of CAD, CAM, and SIM is discussed in the slide. So, firms' operations related to production are incorporated in an integrated computer system to assist, augment, and automate the operations of a factory, which includes CAD, CAM, and SIM functions. And in this integrated system, output of one activity becomes input for the other activity. For example, new products are designed using CAD system. Suppose you have designed one engine, and then you are using that design output to be available for the manufacturing functions, such as process planning. For example, your engine uses one cylinder liner, so you have the CAD details of the engine cylinder liner, with all the tolerances and all that, and that is to be supplied to the manufacturing people for doing the manufacturing planning and actually doing the production of that cylinder liner. And that particular CAD model is again to be used for assembly purposes, because the assembly people want to know how these things are going to fit, how it is going to fit with the piston and all that. And then you have the manufacturing output is provides the input for production planning and control. For example, you made 10 engines of a particular type, and there is a lot of other quantity of that engine to be produced. So you want to order certain material from outside, or you want to send an order to the plant to manufacture or machine some of the other components which you are producing in-house. So all these things are to be managed with the help of is as an integrated system. So that means one activity is dependent upon the other activity or information. So in nutshell, here is the scope of CAD, CAM and SIM. So you can see in this figure you have the CAD and CAM functions or operations like design, analysis, process planning, manufacturing, inspection are the within the scope of the CAD CAM tools or functions. And then you have pay and incentives, business functions, material requisition planning. So they are some kind of business functions, and they are within the all these are the within the scope of the SIM. That means CAD plus CAM plus other business related or factory management related functions are also part of the SIM. Here are some computerized elements of SIM. As we have discussed, the SIM contains a CAD. So that means whatever things you can do with the help of computers for CAD are included in this, like geometric modeling, engineering analysis, automated drafting. Then you have manufacturing planning. Some of the CAM tools that you can use, software tools or hardware, CAP, computer-aided process planning, ANSI programming, work standard, MRP, all these tools you can use. And there are some tools you can use for manufacturing control, just like shop floor control, computer-aided inspection, shop floor control. This is just a repetition. So all these are the at the core of this SIM is the factory operations, which are being done with the help of with the support of these computerized tools. And on the other hand, you have the computerized business functions like order entry. Suppose you the company receives an order for producing say 20 engines of a particular type. You know. So that order is to be punched within the system so that the information flows to all the other stakeholders. You know. Then how the people are coming to do the factory operations, because each of the technical persons or management persons, they are assigned some kind of a role to do the factory operations, and how that is linked to their salary and payroll as well as incentives, and then that is being used by the accounting people also. So all these functions are again interrelated. So these are the computerized elements of SIM. All these activities of SIM are thereby required to have access to a common database. So in the previous slide, we have seen the CAD, CAM and SIM computerized elements. Now here you can see there is a common database which is being accessed by all the functions, whether it is design functions, whether it is manufacturing functions or SIM functions. Also, there is a this shows a common database pipeline which is being accessed. So I missed two lines over here. Please draw that. And this is what we have in the common database. Then these are the functional areas of SIM. Uh, like because everything we divide to some kind of functions or departments. You